Hello, mentors. Welcome to the rooms. So this is in meeting 3, part 1, and then this activity 2, rooms, which is optional if you have more time for the reasoning. So this is 20 minutes, but it's fine if you spend instead of 10 minutes more like 20 minutes in reasonings. Otherwise, this can be a really handy activity if you have students that are really creative and want to really pursue open activities. So we'll create groups corresponding to specific sets of músicos and find their size. Let's take a look at it. And so the gato floor, let's see. So this is after reasoning in which students already played flexibly with the trees. And now they play even more flexibly, creating new sets of músicos. So the people at the fiesta play a game that only allows certain músicos to enter a given floor of the house. For example, only músicos that are gatos. So how many músicos can enter the gato floor? And then what percentage of the músicos are gatos? How can you visualize it? So this is a quick warm-up, the gato floor. And again, going back to the old video that we just did, we can do the following, Since we're caring about gatos, then it would be a great choice for this tree to start with the face or the head, right? It's the same face or head. Let's see, put it here. So let's say I'm choosing the face in this first level. And then I choose the other three in whichever order. I don't really care. We'll see why. And let's say that these are the gatos in this first choice. So we readily see that below this choice of gatos, we have to choose 3 for the bodies, times 3 for the jaranas, times 3 for the gifts, so that's 27. Or another way to see is that we have 3 copies of the same exact tree, not in terms of options, but in terms of the size. So it must be 1/3 of the total. And then we 33.3%. So that would answer this. You can discuss a little bit more and use other representations. So how can you visualize it? With a tree would be the optimal option at this point. Let's keep building on. Gato plus pants. So inside gato, there's a room called only gatos that wear pants. So we already have all the gatos, but now they have to wear pants. So the suit, right? The suit. Take a look here. So this guy here. So what we could do is, okay, we got it right, the body. But otherwise, if this were the tree, we would say, okay, let's pretend that we build our tree this way, just for convenience. And so we're thinking about the pants. We don't have to put it here in the left. We can put it in either of those, so it doesn't really matter. The simplest is to put it here, but you could also put it here. So what's nice is that this partial tree here represents exactly at the end the gatos that wear a suit, some pants. And so you can see again that it's 9. There's 9 options. 3 times 3. You could also see that if you look at it the following way, that you have 9 copies of the same structure. It's not the same tree, but again, it's the same counting, right? So it has to be 1/9 of the total. Right, because so there are gonna be copies of combinations of jarana gifts, but for different faces and bodies. And we're just grabbing those 9 that corresponds to gatos that wear pants, that wear the suit. And so this is a nice way to visualize it, right? 1/9. Okay. Actually, the question is, what is a question that you could ask about this room, about the gato pants? So you could ask how many there are, how many they're not there, what's the percentage. You could also ask what's the percentage, what percentage of the gatos wear pants. And you could also see readily that it's 1/3. So lots of different questions relative to the totals that you could ask. You could also ask, what if it's not a gato that wear pants, but a human that's wearing pants? And the answer is, again, the three, as you can see, hopefully this convinces that it's very powerful to visualize and think about properties, abstract properties, without even doing any calculations. So how many humans wear pants? Exactly the same, right? Is the same. Or how many humans, let's say, this is a nice one. Let's say how many humans have chocolate. So depending on the gift, have bread, depending on the gift where it is. Let's put it here, maybe. So that is our next to last choice. You would have, so regardless of the body, for the gift, it would be here. A bread, and a bread, right? So you can see that there's 9, 3 times 3 times 3. There's 9 humans that carry a bread for the gift. It's just separated, right, by the choice of this. And the last problem is your own room. That's in the homework. So hopefully you do your homework. Students work in pairs and create a special room, writing a precise condition for accessing that room. They challenge other pairs of students to represent the room and find the cardinality, the number, right? The maximum number of músicos that will fit inside. Then you can even do some overlapping. So what would be an example of a weird room? Let's try to brainstorm rooms that are really, really weird or different than the ones that. So you could think about using logic and maybe using or, and not. I think we already use and a lot, like cats and pants or things like that. But so, for example, you could say músicos that are foxes or don't have chocolate. So yeah, that's one interesting condition. So you'll accept all the músicos that either are foxes or don't have chocolate or both. In mathematics, if you don't say anything, the or means this or this or both. Both options are out. So how would we represent this? So let's bring the fox and the chocolate. And let's try to make sense of this. And again, we can pick whichever order. For example, let's pick the chocolate first. So let's say chocolate is here for the gift, right? And let's say that the face is in the second choice. Might be easier. So that's usually the case. What you talk about, you put it in the first choices, because that way you separate less your final options. So the músicos that don't have chocolate, let's try to locate those. So let's draw a region. Right now, we would have 2/3 of the tree captured here. that they don't bring a chocolate. Okay. And then músicos that are foxes. Well, let's just pretend that for the face, we pick the foxes here. So we are adding to our set 9 options, 9 extra options, because these are the foxes that actually drink chocolate. It's chocolate caliente. And so then you would count these notes. You can do it something like 27 plus 27 plus 9. And that would be the total. So the total is going to be here, these 9 guys, plus all these 27 plus 27, so 54 elements. Another way to count this, so it's like if it's using logic, more logic. So if I am interested in músicos that are foxes or don't have chocolate, I am saying something like not allowed, who is not allowed in my room. So if I'm checking whether you want to enter the room or not, then you have to think about I am making the foxes or don't have chocolate enter. So you would be saying if you are not a fox, be very worried. But if you don't have chocolate, that's fine. But if you have chocolate, then I cannot have you in my room and have chocolate. And hopefully you can reason to compute the size of this. Convince yourself that it's going to be 18. Redrawing a 3 or so, and then doing total minus this. So these are complementary properties, right? So this splits all the set of músicos into 2 parts. So hopefully that shows you some good ideas for this routine. So these more counting. So in part 1, you can be flexible about 1. Let's just summarize a little bit. You can be flexible about this, and you could even spend the whole more counting using 1. And if you have extra time, then you can go for this activity that we just explored. Okay, have fun and see you in a next video.